In this module, we shall study about demand forecasting. We know that the firms behave rationally in the matter of business decisions. The firm needs to plan for the right volume of output, appropriate price for its product, and also the future expansion of its business, and all this in the backdrop of uncertainty. Forecasting is the method which helps in reducing the uncertainty factor by planning the future systematically. The ability to forecast demand accurately helps a firm to determine optimum level of output. We begin with explaining the concept of demand forecasting. After starting this module, you shall be able to know about demand parameters, derive linear estimation, understand about estimation through simple and multiple regression, understand about log linear estimation. We shall now discuss about what is demand forecasting. Definition: demand forecasting is the activity of estimating the quantity of a product or service that consumers will purchase. It can also be defined as a technique of planning and decision making. Categorization of demand forecasting by time period. Short range forecast. This refers to demand forecasting for a period not exceeding a year. It involves decision regarding purchasing, job scheduling, workforce levels, job assignments, production levels. Next, long range forecast. It facilitates decisions regarding new product planning, facility location, research and development. It usually has a time horizon of greater than 3 years. Next, techniques of demand forecasting. There is a wide variety of techniques to forecast demand, and it is very important that the suitable technique is selected. Broadly speaking, the choice of techniques of forecasting depends upon the objectives, time and nature of data and complexity of the technique. For convenience sake, we have categorized various techniques under two broad heads. Qualitative methods. Qualitative methods of forecasting are useful in forecasting for new products, for which no past data is available. Some of the common qualitative methods are consumers' opinion survey. In this, buyers are asked about the future buying intentions of product. A survey can be conducted in two ways: census method, which involves contacting each and every buyer, and sample method, which involves survey of only representative sample of buyers. Next, sales force composite. In this method, salespersons are in direct contact with the customers and hence are in a better position to forecast demand for any product. Next, experts' opinion method. This method of forecasting demand is essentially based on the opinion of experts, either internal or external. Next, limitations of qualitative methods. Presence of element of bias, high time and cost of collecting information, uncertainty of accuracy. Next, quantitative method. These methods should be used when past data is available. Some of the methods are exponential smoothing. Exponential smoothing is a form of weighted moving average in which weights decline exponentially and most recent data is weighted most. It requires a smoothing constant A which ranges from 0 to 1. Formula for exponential smoothing: new forecast is equal to last period's forecast plus A, that is last period's actual demand less last period's forecast. Ft is equal to Ft minus 1 plus A in bracket A T minus 1 minus Ft minus 1, where Ft is equal to new forecast, Ft minus 1 previous forecast, A is equal to smoothing or weighting constant where A is greater or equal to 0 and less than or equal to 1. Exponential smoothing example. Let the predicted demand be 142 units and actual demand for a commodity be 153 units. Let the smoothing constant is 0.20. Then the new forecast will be 142 plus 0.2 in bracket 153 less 142. Our objective is to choose and obtain the most accurate forecast no matter what the technique. We generally do this by selecting the model that gives us the lowest forecast error. Forecast error is equal to actual demand minus forecast value, that is AT minus FT. Let us now understand the trend projection method. Trend projection. It is a powerful statistical tool that is used to predict future values of a variable on the basis of time series data. Time series data are arrangement of the values of a variable in chronological order of days, weeks, months and so on. The assumption in using time series is that past trend is likely to continue. In most time series data, we see fluctuations in the values of the variable over time. This can be explained with the help of the following trend. Secular trend. This refers to change occurring consistently over a long time and is relatively smooth in its path. Seasonal trend. This refers to seasonal variations of the data within a year. Cyclical trend. This refers to a cyclical movement in demand for a product that may have the tendency to recur in a few years. These changes may push economic activity in expansion mode or recession. Next, random events. Typical examples of random events may be natural calamities, social unrest and others. These events have no trend of occurrence, hence they create random variation in the series. Next, trend line. This method is very simple to apply. It is reliable in forecasting demand. One of the very common methods of trend projection is regression analysis. Regression analysis relates a dependent variable to one or more independent variables in the form of a linear equation. The parameters of any demand function can be estimated with the help of regression analysis, considered to be the most popular quantitative method of forecasting. Next, log linear model. Sometimes the underlying trend is not linear but exponential. At such time, we have to use a semi-log equation. Here, the dependent variable is in log form, while the independent variable, usually time t, is in linear form. Therefore, it is known as semi-log equation. Next, simple regression model, one variable case. This analysis deals with a single independent variable that determines the value of a dependent variable. In simple linear regression, we predict scores on one variable from the scores on a second variable. The variable we are predicting is called the criterion variable and is referred to as y. The variable we are basing our predictions on is called the predictor variable and is referred to as x. For trend forecasting, our x variable would be time t. Imagine that we have data on demand for Indian tea in million tons from 2005 to 2012. We wish to estimate the quantity of tea demanded in the future, say 2050. We could use the method of determining the trend equation. Equation for linear trend is given as y is equal to a plus b into t, where y is the dependent variable, b is the slope of the line and a is the y-intercept. The normal equations in this model would be summation y is equal to na plus b into summation t, equation 1. Summation x into y is equal to a into summation x plus b into summation t square, equation 2. Solving the above equations, the following is the value of the beta and alpha coefficients obtained. Beta is equal to summation xy minus n into x bar into y bar divided by summation x square minus n into x bar square. A is equal to y bar minus b into x bar. Once the coefficients are estimated, the trend for future periods can be easily projected. Let us explain linear trend projection using simple regression analysis with the help of a numerical example. The steps are as follows. A. For each data point, calculate Ti square, Ti into Yi. B. Calculate the sums of the Ti, Yi, T square and Tyi. C. Calculate the sums of squares SSX, SSY and SXY, also written as summation T square, summation Y square and summation Tyi. D. Calculate AB using the above formula. Summation T is equal to 28, summation Y is equal to 692, summation T square is equal to 140, summation Tyi is equal to 3063. Mean T bar is equal to 4, Y bar is equal to 98.86. The trend line is QDX is equal to 56.70 plus 10.54 into T. B is equal to 10.54. A is equal to Y minus Bx, which is equal to 98.86 minus 10.54 into 4, which gives you the value 56.70. This is a very useful method because we do not need to have data on the x variable as such. We just need to have a time variable. Normally, we will forecast demand QDX with the help of price Px. Here, we only need to know QDX and time t. It could be some date in future or any date within the time period under consideration. If we wish to know the demand for the year 2007, we have to use the trend equation as follows. QDX for 2015 is equal to 56.70 plus 10.54 into 10, which gives you the value of 162.1. Value of T being 10 stands for the year 2015. Can you imagine that it is possible to estimate the demand for Indian tea in the international market without the help of price of tea? Especially, we are able to predict the demand for tea at a future date or year. This is known as outside sample forecast. If we use the same equation for predicting the demand for year 2008, then it is known as within sample forecast. QDX for 2008 is equal to 56.70 plus 10.54 into 4, which gives you the value 98.86. The actual demand in 2008 is 90. This shows that there is a forecast error of negative 8.86. The actual demand is lower than the predicted demand. It means in that year there was some particular reason for lower demand. Next, multiple regression. Let us now extend our discussion to the case in which there is more than one independent variable. Let us start with the well-known demand function in which quantity demanded of a product depends on its own price as well as on the advertising expenditure incurred A. Let us assume a linear relation between quantity demanded and the two independent variables. Elements of a multiple regression equation. D is equal to A plus BP into P plus B2 into A plus E, where A, B1 and B2 are the parameters and E is the random error term. This model is different from the previous model as the dependent variable depends upon two independent variables. Similar to simple regression analysis, this also relates to estimation of the parameters that will minimize the sum of the squared deviations of the observed values of the dependent variable from its estimated values. Moving on to the log linear model. Logarithmy, transforming variables in a regression model, is a very common way to handle situations where a non-linear relationship exists between the independent and dependent variables. The general trends to study the overall growth rates are also discussed with the help of semi-log equations for any economic variable. The purpose behind Such analysis is to show the annual growth rate at which a variable like demand is growing exponentially. We construct a semi-log regression equation, and for that we have regressed the log of variable with respect to the time. Therefore, regression equation can be written as q dx y is equal to e raised to the power alpha plus beta into t. Equation 1. Taking log of both sides and adding an error term, we have log y is equal to alpha plus beta into t plus ut. Equation 2, where log y is equal to natural log of y variable q dx, alpha is equal to intercept term, beta is equal to slope of the regression equation, which basically tells us about the growth rate. T is equal to time, which is from 1970-71 to 2000-2011, ut error term. Next is steps. First, take natural log of quantity demanded q dx and call it log y. Second, by the simple regression method given above, section 4.1, construct the exponential trend equation. Third, by regressing log y log q dx on time t. Only remember to take natural log, not log to the base 10. Now let us discuss the limitations. First, just as with simple regression, multiple regression will not be good at explaining the relationship of the independent variables to the dependent variables if those relationships are not linear. Second, ordinary least squares linear multiple regression is used to predict dependent variables measured at the interval or ratio level. If the dependent variable is not measured at this level, then other more specialized regression techniques must be used. Third, ordinary least squares linear multiple regression assumes that the independent x variables are measures at the interval or ratio level. If the variables are not, then multiple regression will result in more errors of prediction. When nominal level variables are used, they are called dummy variables. They take the value of 1 to represent the presence of some quality and the value of 0 to indicate the absence of that quality. For example, smoker is equal to 1, non-smoker is equal to 0. Ordinal coefficients may indicate ranks. For example, staff is equal to 1, supervisor is equal to 2, manager is equal to 3. The interpretation of the coefficients is more problematic with independent variables measured at the nominal or ordinal level. Let us now recapitulate what we have learned so far. Demand forecasting is the scientific and analytical estimation of demand for a product for a particular period of time. Demand forecasting can be categorized on the basis of time of forecasting. Trend projection is a powerful statistical tool frequently used to predict future values of a variable on the basis of time series data. An important method of trend projection is the regression analysis. The trend equation is estimated with the help of normal equation. It is possible to do prediction of quantity demanded of x without the knowledge of price of x. Moreover, we can do two types forecasting within and outside sample. Regression analysis relates a dependent variable to one or more independent variables in the form of a linear equation. Regression analysis can be simple or multiple. We have also seen how to estimate a log linear model for demand forecasting when the underlying trend is exponential. Thank you.